Hello everybody. Today I am going to speak about different communication channels. But you see, we have talked about in the previous few lectures, I have talked about the channel being noisy. So in practical situation, always the channel will be noisy and your signal will be weakest at the channel. So how to get error-free communication over a noisy channel? Let's see. The probability of error, that means whenever I am sending a 1, it gets flipped to 0 at the receiving end, means there is some noise in the channel which actually converts my 1 to 0 and vice versa. Now this probability of error given as P suffix E is proportional to exponential minus E k into EB, where here k is a constant and EB is the energy per bit. Now how can we increase EB? You see, when we can increase EB, our probability of error according to this equation will decrease. So this is our requirement. Now we know the signal power, or SI we can say, is given as EB into RB, where EB is the energy per bit and the RB is the bit rate. So how can we then from this equation, from the second equation, increase EB? Either we can increase SI, the signal power, or we can decrease RB, that is the bit rate. But for practical situation, this signal power cannot be enhanced beyond a certain limit, especially for wireless devices. The signal power generation is limited. So we cannot increase SI beyond a certain limit. Then the only option remained is decreasing RB. So as you decrease RB, your EB increases and at the same time my probability of error will decrease. You see here, so to decrease the probability of error, we can decrease RB, and to make the probability of error 0, that means to make it error free, we have to make RB 0. So it is very funny thing, like in the presence of channel noise, it is impossible to get error free communication. Then means if you are not sending anything, there won't be any error. But it is not the actual target. Shannon in 1948, he showed that if RB is decreased to a certain extent and if it remains within the channel capacity as we have discussed earlier, then we can get error free communication. That is, RB should be less than CS, where CS here is the channel capacity. Now let us deal with now discrete memoryless channel. We have already talked about discrete information sources and memoryless information sources, which means discrete means we are having some discrete values of information sources, and memoryless means the symbols that are generated are not they do not have a memory, or they do not depend on the past values. So our idea is to create a discrete memoryless channel. Let's see the block diagram of it. We are inputting some random variable at the input of the discrete memoryless channel, which is the X, and we expect to get some random variable at the output. Now if this channel is error free, then Y will be exact replica of X. But due to some channel noise, we get some error and there is some probability of error which is given as PE. Now let us look at one example of binary symmetric channel. It says that X and Y are the binary random variables representing the input and the output of this binary symmetric channel. Now the channel transition probability is given below. What is the transition probability? Probability of receiving 0 when X equal to 0 has been transmitted, that is, there is no error in the system, it is 1 minus P. Probability of receiving 0 when X has been transmitted, that means there is some error, so the probability of error is P. Similarly, probability of receiving 1 when X equal to 1 has been transmitted is 1 minus P, that means no error case, and probability of receiving 1 when 0 has been transmitted, it is again the error case, which is having a probability of P. Now P x equal to 0 means the marginal probability of transmitting x equal to 0 is 0.5 and marginal probability of transmitting x equal to 1 is also 0.5. You need to find out the probability of receiving 1 and 0 at the receiver. Let us look at the solution. The probability of receiving y equal to 0 is given as probability of transmitting x equal to 0 multiplied by probability of receiving 0 when x has been 0 has been transmitted plus probability of transmitting x equal to 1 multiplied by probability of receiving 0 when x equal to 1 has been transmitted. But why is this so? There you see the probability of receiving 0 are two ways, like you are transmitting 0 and receiving 0, that means there is no error. Also you can receive 0 if 1 has been transmitted, if there is some error with probability p. So if you put the values here, the answer will be 0.5. Similarly, what is the probability of receiving 1? You see the probability of receiving 1 means you can receive 1 either by sending 0 having a probability of error p, or you can receive 1 when you have already sent 1 with no error, that means 1 minus p probability. So if you put those values again in equation 2, you can get again it is to be 0.5. So the probability of receiving 0 is 0.5 and probability of receiving 1 is also 0.5 in this case. Let us look at another example. Here over a certain communication channel, the symbol 0 is transmitted with probability 0.4 and 1 with probability 0.6. It says if p epsilon 0 is equal to 10 to the power minus 6, that means it is the probability of detecting error when xi has been transmitted, when xi is 0 over here, and probability of detecting error when 1 has been transmitted is given as p epsilon by 1, and it is the value that has been attributed to it is 10 to the power minus 4. You have to determine the error probability p epsilon of the channel. Let's see. Here p epsilon comma xi is called the joint probability, that is xi is transmitted and detected wrongly. Then probability of error will be given as summation of all the probabilities of error when xi's have been transmitted. So we can write it as summation p epsilon comma xi. So we can write it as again p of epsilon comma 0, that means when there is error for transmitting 0 plus probability epsilon comma 1 when there is error while transmitting 1. Now what is probability of error when 0 has been transmitted? It is probability of transmitting 0, that means p of x0 multiplied by probability of error 0 plus probability of x1, that means probability of transmitting 1 but you are receiving it wrongly, so multiplied by p epsilon 1. Now we are putting the values. See, p of x0 has been given as 0.4 and p of epsilon by 0 is given as 10 to the power minus 6 plus 0.6 is the probability of transmitting 1 multiplied by 10 to the power minus 4, which is the probability of error of transmitting and receiving 1. Upon calculation, we find the result is 0.604 multiplied by 10 to the power minus 4. So total probability of error when 0 has been transmitted is 10 to the power minus 6. What does that mean? This means that 1 out of 1 million received zeros are detected wrongly, and probability of error when 1 has been transmitted is 10 to the power minus 4, which means 1 out of 10,000 received ones are detected wrongly. So total probability of error will be 0.604 multiplied by 10 to the power minus 4 as found out in the previous step. This means 1 out of 1 by 0.604 multiplied by 10 to the power minus 4, that means 16556 digits will be in error regardless of ones and zeros on an average. So this is the general idea of binary symmetric channel. Now we move over to binary asymmetric channel. Binary asymmetric channel is also a communication channel model where the only difference is that the probability of transmitting 0 and receiving 1 is different from probability of transmitting 1 and receiving 0. Here I have given a problem where the probability of transmitting 0 and receiving 1 is P naught, and probability of transmitting 1 but receiving 0 is P1. So probability of transmitting 0 and receiving 0, that means no probability, no error, so it is 1 minus P naught, and probability of transmitting 1 and receiving 1 is 1 minus P1. So that is binary asymmetric channel because these two probabilities are different. Now the values are given over here. We need to find out the probability of receiving 1 and 0 at the receiver, as in the previous case of while I was talking about binary symmetric channel. Now here in this case, as before, we need to find out P of y equal to 0, that means probability of receiving 0. Again we put the expression and we get it as P of x equal to 0 multiplied by P of y equal to 0 by x plus P of x equal to 1 multiplied by P of y equal to 0 by x equal to 1. So if you put the values, in this case we get 0.5 times 1 minus P naught plus P1. And similarly, if you calculate P of y equal to 1, putting the values here, we get it as 0.5 into 1 minus P1 plus P naught. So this is called the binary asymmetric channel. So today we have learned about the different types of communication channels. We started with binary symmetric channel, we studied some of the problems related to binary symmetric channel, and then we moved over to binary asymmetric channel and looked into one problem. Thank you.